We shall now be studying the ordinal utility approach to consumer behavior and demand analysis. When you study this module, you would know the assumptions and properties of the ordinal approach. You would understand consumer behavior according to this approach. You would be able to identify and examine the Slutsky theorem and evaluate the difference between normal, inferior and given goods as per this approach. First of all, let us understand what we mean by preferences. Preferences in the ordinal utility approach are relationships between bundles of two commodities. If a consumer chooses a bundle X1, X2 when Y1, Y2 is available, then it is natural to say that the bundle X1, X2 is preferred to the bundle Y1, Y2 by the consumer. Preferences have to do with the entire bundle of goods and not with individual goods. In an ordinal sense, therefore, the consumer is placing a greater emphasis on one bundle as against another, on one commodity as against another. Consumers can rank various consumption possibilities, and the way in which the consumer is able to make out the difference between different bundles is according to the ranking of the consumption bundles which describe the consumer's preferences. Therefore, here utility is not being measured in absolute terms, it is in relative terms, and it is in terms of ranking of the preferences. Now, let us consider indifference curves. In the case of indifference curves, we would say that X1, X2 is greater than Y1, Y2, which means that the bundle X is strictly preferred to bundle Y, and therefore we would place X1, X2 above Y1, Y2, and which means that bundle X is regarded as being preferred to Y1, Y2. But on the other hand, if the consumer treats both X1, X2 and Y1, Y2 as being equal in order, then we would say that the bundle of X is, or the consumer is indifferent between the bundle X as compared to the bundle Y. If X1, X2 is greater than Y1, Y2, it means that bundle X is at least as good as bundle Y. The indifference curve graph actually it consists of a set of bundles that are indifferently weakly preferred to some other bundles. But let us not confuse indifference with non-knowledge. What it means is that a consumer is clearly placing equal emphasis on both bundles and therefore is indifferent between x1, x2 and y1, y2. Now, about the assumptions regarding the ordinal utility approach. The first assumption is known as the reflexive assumption. Any bundle is at least as good as itself. The second assumption is known as the completeness assumption. Any two bundles can be compared, that is, a consumer is able to make a choice between any two bundles. If X and Y are any two bundles, then the consumer can always specify exactly one of the following possibilities: X is greater than Y, Y is greater than X, or X and Y are equally attractive. Transitivity. If X is greater than Y and Y is greater than Z, then X would be greater than Z. What it says is that if the bundle X is strictly preferred to bundle Y, then bundle Y is strictly preferred to bundle Z, then bundle X is also strictly preferred to bundle Z. Rationality. The consumer is assumed to be rational. The objective of the consumer is to maximize satisfaction. Well, of course, this is under conditions of given income and prices of the given commodities, let us say X and Y. Utility is ordinal. The consumer can rank his preferences according to the satisfaction from each bundle. Then we have another concept, another assumption, that is diminishing marginal rate of substitution. Preferences are ranked in terms of the indifference curve, which are assumed to be convex. This implies that the consumer will be willing to give up lesser and lesser amounts of one good in return for another as he moves down the indifference curve. That is, as the consumption of X increases, then the amounts of Y that the consumer would be prepared to forego for getting each additional unit of X would constantly go on diminishing. So now let us, on the basis of these assumptions, look at the properties of indifference curves. An indifference curve has a negative slope, which denotes that if the quantity of one commodity decreases, then the quantity of the other commodity would increase and vice versa. This is obviously necessary because we are considering two commodities X and Y which are substitutes, but the substitution along an indifference curve is done in such a manner that the total satisfaction obtained from the consumption of different combinations of X and Y always remains the same. Then the further away an indifference curve is from the origin, the higher would be the level of satisfaction, because as the indifference curve goes higher and higher, it is possible for the consumer to consume more of both commodities X and Y. There is no need for, or in fact there no trade-off exists between X and Y. so long as you are not on the same indifference curve. Then, thirdly, indifference curves do not intersect each other. If they did, then at the point of intersection, we cannot really say what would be the relationship between the level of satisfaction that lies along two different indifference curves. So therefore, it is necessary to assume that they do not intersect each other. Indifference curves are convex to the origin. As has just been explained, it implies that the slope of an indifference curve is, of course it is downward sloping, but the curvature of the indifference curve is such that as we move from the left to the right and as the consumption of x increases, then less and less of y is foregone for obtaining one additional unit of x. Now, these are the assumptions. And now let us look at consumer equilibrium. Under the ordinal utility analysis, once again we define the utility function. The utility in this case is derived not from the consumption of one commodity but from the consumption of two commodities x and y. Therefore, the first equation which gives us the utility function is described as u is equal to f of x and y, that is the utility obtained from the consumption of x and y is defined in the utility function, such that the utility derived from both at different points on the indifference curve is always equal to a constant. Therefore, on the right hand side we say that u is equal to f of x y, which is equal to k, which is a constant. This is our equation 1a. Now, to ensure that the total utility is constant, we differentiate the utility function, and therefore we have the partial differentiation of the utility function with respect to y multiplied by the difference in y plus the partial differentiation of the utility with respect to x multiplied by the difference in x. This is nothing but the Euler's theorem for partial differentiation. Now, this can be simplified by writing marginal utility of y in place of the partial differentiation in the first case and writing marginal utility of x in the second case. Now, this equation reads as du, which is the change in utility, is equal to marginal utility of y into dy plus marginal utility of x into dx. This is equation 2a. Any change along the indifference curve implies that the total utility is constant. Therefore, this whole expression du is equal to mu into dy plus mu x into dx is equal to 0. If we transform this expression, then it would read as minus of dy by dx is equal to mux by muy, which is equal to nothing but the marginal rate of substitution. What does it say? It says that since x increases, the marginal utility of x falls, and since y decreases, the marginal utility of y rises. Therefore, it stands to reason that dy by dx, which is nothing but the slope of the indifference curve, will always fall as we go along from the left to right. That means as the consumption of x increases and the consumption of y decreases. We often find it useful to refer to the slope of the indifference curve at a particular point of time, as we have said, is the marginal rate of substitution of x for y. So this is known as MRS xy, and the name comes from the fact that the marginal rate of substitution measures the rate at which the consumer is willing to give up 1 unit of a commodity to obtain another unit of another commodity. This rate goes on declining. So, considering this, now the next question is that when the marginal rate of substitution of x for y is falling, the consumption of x increases and hence the marginal utility of x declines. Automatically the consumption of y declines and the marginal utility of y increases, and hence the ratio will always decline. So this is about one part of consumer behavior. Please notice that so far we have not introduced anything in the nature of either the prices or the income of the consumer. Now we will be considering what is called the budget constraint of the consumer. Suppose there is a set of two commodities from which the consumer has to choose, as we have been saying, x and y. Then in real life, of course, the consumer has to choose amongst many commodities, but it is convenient for us to consider only two commodities, and graphically it is possible to represent the choice between two commodities in the xy space, and that is also a reason why we restrict ourselves to two commodities. Any utility maximization problem is defined in terms of a given budget constraint. A consumer in real life also always faces a budget constraint because he doesn't have unlimited income. A consumer has a given income which is constrains the behavior. The income constraint in the case of two commodities may be written as M is equal to P of x into Q of x plus P of y into Q of y. We may present the income constraint graphically by the budget line by solving for Qy in the next equation, and this is how equation 6 reads: Qy is equal to 1 upon Py into M minus Px upon Py into Qx. So the slope of the budget line is the derivative of the budget of the above equation, which is negative, and this can easily be transformed into the ratio of the prices of the two commodities. So in short, what we are saying is that the slope of the budget line actually represents Px upon Py. So now we have two conditions, one which defines the preferences and the satisfaction and the consumer behavior in terms of how a consumer substitutes one commodity for the other and how it affects the utilities. And on the other hand, we have a budget line which shows how there is a constraint and there are a set of prices for x and y, and now we have to combine both these features of consumer behavior, one which arises out of the satisfaction, utility and preferences of the consumer, which mind you is actually in the mind of the consumer, and the other set of information in terms of prices and income. These are things which are obtained and exist in the market. So please remember that consumer equilibrium is a transaction, it's an intersection between the consumer's preferences, which are psychological, and the real conditions in the market. We now put together the budget constraint, the budget set, and the theory of preferences in order to examine the optimal choice of the consumers. The economic model of consumer choice is that people choose the best bundle. However, the best bundle has to be one which the consumers can afford. The consumer is in equilibrium when she or he maximizes the utility given the income and the market prices. The two conditions must be fulfilled for consumer equilibrium to take place. The first condition is that the marginal rate of substitution should be equal to the ratio of the commodity prices. This is the bundle, that is at a particular bundle this happens where the budget constraint is tangential to the highest possible indifference curve. An important feature of this optimal bundle is that the choice is where the indifference curve is tangential, and hence it is an equation between the slope of both the indifference curve and the budget line. Therefore, the slope of these two must be equal when the choice is optimal. We express this as MRSXY is equal to MUX upon MUY is equal to PX upon PY. This equilibrium condition is a necessary condition but not a sufficient condition. The second condition is that the indifference curve should be convex to the origin, and this is ensured by the axiom of diminishing marginal rate of substitution. Considering all of this together, consumer equilibrium is to now be analyzed. Let us imagine that there is an indifference map and the consumer has a budget line. The equilibrium is defined by the tangency of the budget line with the highest possible indifference curve. Here BC stands for the budget constraint, and then you have indifference curves I1, I2, I3 and so on, and X star and Y star are the quantities consumed respectively of commodity X and Y. Under consumer equilibrium, the slope of the budget constraint BC is Px by Py, and the slope of indifference curve number 2 I2 is Mux upon Muy, which is the marginal rate of substitution. The points that lie along I1 are inferior to I2. The points that lie along I3 are superior to I2 but are out of bounds for the consumer since they lie beyond the budget constraint. The only point which represents the highest attainable indifference curve is I2, and it is the one which achieves the maximum satisfaction at the point of tangency between the budget constraint and I2. Therefore, it results in equilibrium and the maximum satisfaction to the consumer. Now, this consumer equilibrium could be used for understanding various phenomena. First of all, we would like to know the nature of this whole process of substitution between X and Y, and for this we have a theorem called the Slutsky theorem. The Slutsky equation breaks down a change in the demand due to price change into substitution effect and income effect. The equation takes the form of dx upon dpx, that is, we are differentiating with respect to the price of x, and is equal to dhpHx by dpx minus x of dx upon dm. The term on the left is the change in demand for commodity x with respect to the price of x. Here x is the Marshallian demand for a good and px is the price of that commodity. The term h is an Hicksian or the compensated demand. The term dh by dp measures the substitution effect. The term m is the income, and therefore x dx by dm measures the income effect. When we read the Slutsky equation, the term dhx upon dp is the substitution effect, and this is because the compensated demand depends upon h of px, py and u, which fixes the consumer's utility level when the consumer's purchasing power remains constant. And that is, the indifference curve remains constant. So the purchasing power, indifference curve, or what we could call the real income, all of these can be used interchangeably. The term dh upon dp only measures the shift in consumption when price alone changes. On the other hand, the income effect depends upon the amount of the goods the consumer is consuming of x and the consumer's reaction to a change in income, which is dx with respect to dm, that comes from savings or release of additional real income due to the fall in price of x. That's the term x of dx upon dm measures the income effect. Now, if we look at, then we can examine the income and substitution effect for normal goods. In the case of normal goods, we start from point E1. At this point, indifference curve 1 is tangential to the budget constraint AB, and when the price of x falls, then there is a compensated budget line, which is the dotted line, and then what happens is the slope is now lower. Therefore, because x is now cheaper, the consumer would like to shift away from E1 to E1 prime, and at E1 prime the consumption of x increases from x1 to x1 prime. But please note that the fall in price has led to an increase in income, but because the consumer is still remaining on indifference curve number 1, therefore the purchasing power or the real income has been held constant. Now, so initially we have changed or lowered the price without increasing the real income. Now, in the second stage, what happens is that we restore the additional real income which should be available to the consumer because the price has fallen. In doing so, we make another budget line AB prime, which is parallel to the dotted line, which is the compensated budget line. Now, what happens is that the indifference curve number 1 is within the new budget constraint AB prime. The consumer would not like to remain here and would like to move to a higher indifference curve which is now available, and hence the consumer moves away from E1 prime and goes to E2. At E2, what happens is that the consumption of X increases from X1 prime to X2. So, the total consumption of X has increased from X1 to X2, but this has taken place in two parts, first from X1 to X1 prime and then from X1 prime to X2 prime. The first shift is the substitution effect because it is taking place because of the pure effect of change in price without any change in the real income. And the second effect is the income effect because it represents the increase in consumption due to an increase in the real income while the price, which has already been adjusted for, remains the same. So therefore, the total change from X1 up to X2 is the price effect. What do we mean by effect? Effect is the quantitative change. So the quantitative change that takes place due to a fall in price of X is that the consumption in quantity has increased from X1 up to X2. It has partly increased because of the substitution effect from E1 to E1 prime, and consequently the demand has consumption has increased from X1 to X1 prime. This is the substitution effect, and the income effect is the change from X1 prime to X2 when the price is remaining constant. So therefore we can say that price effect is equal to substitution effect plus income effect. What is the difference between price effect for normal goods and for inferior goods? When we consider price effect for normal goods, then the price effect would be equal to substitution effect, which is positive in the case of a fall in price, plus the income effect, which is positive again in the case of normal goods. That is, if the income rises, then when it is the case of a normal good, you would like to consume more of that commodity. On the other hand, in the case of inferior goods, what happens is the substitution effect remains the same, but the income effect is negative because these goods are considered to be inferior. So as the income increases, you would like to consume relatively less and less of the commodity. So when price falls, real income increases, but you tend to consume less of that commodity. Therefore, in the case of inferior goods, the income effect is negative, but so long as the substitution effect is positive and the negative income effect is less than the substitution effect, we are still only having a negative income effect. Okay? But now let us consider the case where the price effect is from the movement is in figure number 3, the movement is from A to C, and here the price has fallen and the consumption has increased from Q11 to Q1 star. But on the other hand, the income has not increased, the income has been restricted, and the additional income has not been given back to the consumer. Now if we then allow for the compensating change, then what would happen is that the budget line would shift parallelly and would go to BL2. what happens at BL2 is that the real income has increased, but the commodity X is an inferior good, but a peculiar inferior good, because the income effect is not only negative, but it is larger than the substitution effect. Please remember that the substitution effect was from Q11 to Q1 star. Now, from C to B, the movement shows that the consumer's negative income effect is from Q1 star up to Q12, and this is greater than the gap from Q11 to Q1 star. Hence, what is happening is that the negative income effect outweighs the positive substitution effect. So, the movement from A to C and C to B results in the final consumption of commodity X remaining at Q12. That means that with a fall in price, the quantity demanded or consumed of commodity X has actually fallen from Q11 to Q12. So, if price falls and along with that if the quantity consumed also falls, then this is an anomalous situation, and this anomalous situation arises because negative income effect outweighs the positive substitution effect. What you would notice is that whether it's a normal good or a inferior good or even a giffen good, the substitution effect always remains positive for a fall in price. Now, there are some limitations that the indifference curve analysis suffers from. There are certain axiomatic conditions which are assumed. It requires a precise ordering of preferences, and it has a strong rationality assumption. Now, let us summarize what we have done so far. And a consumer is aware of his preferences. A consumer can very clearly say how he prefers or is indifferent between different bundles of X and Y. A consumer faces a budget line, a set of prices and income, and chooses the highest indifference curve. When he does so, then he is in equilibrium, he is getting the maximum satisfaction, and the indifference curve is tangential to the budget line, and at this point there is equilibrium. In the case of a normal good, we have the typical relationship, that is price effect is equal to substitution effect plus income effect. In the case of an inferior good, the income effect is negative but not greater than the substitution effect. So, the price effect for a fall in price always remains negative. In the other case of the giffen good, the negative income effect is so strong that it outweighs the substitution effect, and ultimately for a fall in price we actually land up having a positive price effect. That means price falls and consumption also falls along with it. Such a case is known as the giffen good, and a typical example of the giffen good is that of diamonds. In the case of diamonds, there is what is called a snob appeal, that if a diamond costs less, then you would not like to purchase it. If a diamond costs more, then you will demand more of it.